Hi everyone. In this problem, we're going to solve coin change. We are given an integer array coin representing the coins of different denomination and an integer amount representing a total amount of money. Return the fewest number of coin that you need to make up the amount. The amount of money cannot be made by any combination of the coin, then you have to return -1. We may assume that we have an infinite number of each kind of coin. So whenever you get an infinite number of each type of coin, then you can think of dynamic programming. And in dynamic programming, you can think of unbounded. 0, 1 knapsack. So here, right, what is the given problem, right? So we're going to have amount, so 11. So our DP would be of size. There would be 11 values. And here, right, from here we can start filling. So we can fill one. So to reach a zeroth cell, right, it will always going to have one because we can reach zeroth without any problem. To reach one cell, and all of this, right, we are going to initialize with infinity initially. So it would be initially infinity. Now to reach one, we can use one coin, and we can reach one. So we can reach two. We can keep on filling it up till we reach 11, and our results would be in DP of -1. So last cell is going to contain the minimum, and to fill it up, right, we are going to check the current value. So this formula would be, right, DP of current index equal to minimum of DP of I, or DP. We can also fill it from the backward direction. It is up to you. So I can say I minus coin, and this is going to give the result. Also, right, this would be a bottom up approach of creating a tabulation table, but the time complexity out here, right, would be smaller, but it would be like big O of amount multiplied, so 11 multiplied by total number of coins, so n. So in this case it would be 33, the maximum time complexity. So now there would be another approach, so which would be like, this is a bottom up approach. We would like to do the top down approach. So here, right, for top down approach you have to do a recursive solution. So in our recursive solution, right, we need to understand what is going to be our base condition. So here, right, we are going to create a function dfs, and we are going to pass in the value. So initially, right, the value would be 0. So whenever I call this function, this would be def, and this we are going to call this function, so dfs of 0. So the first base condition, right, in case, right, our current value is going to exceed the 11. Let's say we are going to form we have to form till 11 value, but we have taken 5 plus 5 plus 5, right, and we have reached 15. So we have gone out of bounds. So in that case, right, if I say if the value is greater than the amount, so in that case, right, I can return float infinity, or I can say return infinity basically, because in that case, right, we are not been able to found a solution by using this number of coins we have reached 11. Now if the value is equal to amount, then we have reached a solution. So I can say return 0, and we have to use a DP, right, to store our solution. Let's see if we don't use an DP. So for that example, so now I have to write a for loop. So I can say for coin in, so we're going to take all the coins, right, and here I'm going to call this function, so DFS, and here I'm going to pass in whatever the current value is plus coin. So it would be like initially, right, it would be 0, so it would be where we can draw the recursive tree. So we can use 1 coin, 2 coin, and 5 coin. So current value would be 1, 2, and 5. Then we can again use 1 coin, 2 coin, 3 coins. If I use 1 coin, it is going to take make the value 2. So if I use 2 coin, it is going to make it 3 and 4 in that direction. Similarly, it will keep on going iterating. So that is the idea. So this loop is going to end, right, or the base condition would be, right, if this current value is going to exceed the amount. In that case, it is going to end. And whenever we are going to, like, this is one path, right, so every path would be like one value. So I can say, so initially, right, I can say minimum ways, and I can initialize with infinity. I can say min ways, and I can say 1 plus whatever the value would be. So this would be the value, and if I look into, or if I draw it down, right, without memoization, then I can get my result, and I can say return. After all of this is done, I can say minimum wage is going to be my value. This would be my output. So here, right, we have to, very important for us to create the base condition where our recursive tree is going to end. So these two are going to be our base condition. If we're going to do top-down approach or using recursive and memoization, and if we're going to do bottom-up approach, I feel personally bottom-up approach is difficult to come up. This is a easy solution, so you might be able to get set properly, but there could be a situation where coming up with a bottom-up approach is pretty difficult. So in that case, right, generally try, if you're fine with recursion, right, try to apply recursive approach, and bottom-up approach you can look down. Now once you have done it right, now let us jump to the Python solution where I'm going to show you the code. And in the code, right, I would be trying to solve it with using a recursive and memoization. So the first thing that we require, right, we need to create our function DFS, and here we are going to do the recursive function, and I can say the current value, and I can call this function, so DFS, and initially the value would be passing at 0. So initially we have 0 amount, and I can assign it to result. So once that is done, right, we have to write our base condition, and before that also, right, we have to draw the memoization table. So we initialize our DP of empty dictionary, and here, right, the first recursive condition is that if my current value is greater than amount, then I can say, right, we have exceeded and we are never going to get the proper value. So I can say return float infinity if, or let's say elif value equal to amount, then I can say return 0. We found a proper case. Once that is done, right, I can say minimum ways of forming it or reaching the amount. So initially, right, it would be float infinity, and now I can say for coin, I'm going to loop through the entire array of coin. So for coin in coins, I can say min way equal to minimum of min way or 1 plus, because whenever we are taking a coin, right, so we are adding one combination or one coin to form the amount. So it would be DFS, and I can say value plus whatever the value of the coin that we are using it up. So now I can say return min way. Now if I run this code, right, it should work fine. Yeah, there is one more error. We have to create a memoization table. So I can say elif value is already in DP. So I can say return DP of value. And here what I can do, I can assign it to DP of value equal to min way, and I can return DP of value. Let me run it up. Yeah, I forgot to return. That's a mistake. So return result. So here, right, it is expecting -1, but we're getting null. So reason being, so we're going to return result if result not equal to float infinity. So in case, right, we are never going to able to form the amount using the coins. So in that case, we can return -1. So let me run it back again. As you could see, the code ran successfully. Let me submit the code. The code submission is successful. It is beating 12.52, but if I submit it again, right, it would be in the range close to 40s or 50s. But if we do a memoization table, right, obviously the code would be way more faster. But I feel, right, to draw the recursive with memoization table is more intuitive for me to come up with a solution. So I generally prefer writing the code in this format. But if you are comfortable with an bottom-up approach, you can obviously try to do that. Saying that, that's all for this video. See you in the next one.